Yeah, this talk is about SMS, external SMS interface for Osmo MSC, not USSD anymore. And I'm going to talk about SMS in general. What is it? Some interesting facts about SMS. How does it work in commercial networks, MAP or TCAP based, and how is it implemented in Osmocom infrastructure. So what's SMS for a regular user? It's a kind of service that enables you to exchange short text messages, and it's basically available in almost any network and supported by almost any phone today. And for an Osmocom developer, it's first of all it's a protocol stack, and it's kind of complicated protocol stack. There is like control layer, relay layer, transport layer, and only then application layer. That's exactly where you type your text. And it's a nice target for fuzzing. There is a talk, SMS of this. And they actually managed to break some phones during this fuzzing session. If you're interested, you can check it out. And some the most important specifications, as Harald already mentioned, there are basically two kinds of SMS. One is cell broadcast, and this is behind the scope of my talk. I'm going to talk about point-to-point SMS. Well, the first specification is mostly about the transport protocol. The second one is about the control protocol and the relay protocol. And of course, MAP, it describes how should different parts of the core network infrastructure interact with each other. So some history. The initial idea of having short messages appeared in early 80s. So there was kind of cooperation between two German and French guys. I don't remember exactly. Friedhelm Hillebrand, and Bernard Gilli. Oh. Anyone knows how to pronounce this correctly? Gilbert. Okay.
I don't know where it is.
And the second line, yes. Anyway, so in 1984 they developed the initial context of SMS, concept of SMS messages, and the key idea was to use signaling channels of GSM. At that time, it was highly voice optimized, and we see similar problem today with LTE. It's a pure packet switched, and there is almost nothing for SMS and for USSD and even calls. And Hillebrand actually analyzed some teletext messages and something else, I don't remember, and decided that this limitation, 167V characters, should be enough for everyone to express all the minds. And Twitter actually is following quite similar limitation, but actually it's 140, as far as I remember, for any kind of... Well, because you can tweet using SMS.
Yeah, and the prefix is wider.
Yes, it will be something about it later. So in February 1985, the first proposal of SMS that he initiated actually the development of SMS. So it was accepted, approved by GSM Group. And in GSM 0203, there were specified two types of SMS, SMS point-to-point and SMS telebroadcast. And in December of 1992, the first SMS message with text "Merry Christmas" was sent. And it was in the UK over a Vodafone network. And then in 2010, around 6 trillion SMS text messages were sent. And today, I think they are mostly deprecated by some instant messengers like Telegram and so on. They don't need to pay. But still, they are actively used for like two-factor authentication or some different notifications and so on. So some interesting facts about SMS, like SMS can not only be sent to your phone, it can be sent to your SIM card or from SIM card. And you can watch The Secret Life of SIM Cards for more details. They can also like establish GPRS channels. That's not the limit. And another interesting fact is that the SMS can be basically sent over GPRS, and that's more efficient, unlike SDCCH, because packet switch domain is kind of TDMA over TDMA, and multiple subscribers can share the same time slot. And I think, personally, that silent SMS doesn't make any sense, because you can basically just establish an SDCCH channel, and the result would be the same. If you have any ideas about it.
You can establish a channel if you have control over the base station or the BSC, but if you're an outside operator and you have only interface to a SMSP, then silent SMS makes sense because you don't control the network. So whatever the network operator is providing a service to law enforcement or whatever, their silent SMS makes sense.
But I think they could provide some kind of service that would just establish an SDCH channel instead of designing this behavior of mobile station just to receive and not indicate this SMS arrival.
You have SMS going to SIM card and stuff like that, like applications, other than the showing to the user?
Yes, yes. But this silent SMS, I don't know, for me it's kind of useless. Just to establish a channel. Maybe there are some other use cases.
I mean, if you want something to establish a channel which is both authenticated and...
Yeah.
Yes. If you want to establish a channel that is authenticated and ciphered, at one timeout, you actually have to start a transaction with the MS and actually do something.
Okay, makes sense.
So that could be used for that.
Okay, and as I already mentioned, you can tweet using SMS. And I think Twitter was inspired by this limitation. And why do we need an external interface for SMS? Well, we have kind of built-in SMS center in Osmo MSC, but it's a kind of rudimentary implementation from old network-in-the-box times. It's very limited and buggy. Like a few weeks ago, I've been writing some unit tests for it, and it's far from being perfect. And normally, SMS Center is a kind of separate entity of GSM network, and we need to be able to talk to some commercial implementations of SMS centers or implement our own SMS center. Or if you even have multiple mobile switching centers, they definitely would need to connect to some single SMS entity. There is no need to maintain separate databases. And Osmo MSC also does support SMPP protocol, but the problem of this approach is that it involves some kind of transcoding between TPDU, the transport protocol, and SMPP protocol, and that may be something that's not desired. And I will make it a bit. Yes, so this is kind of graphical representation of the SMS protocol stack, and it's a bit different on the radio access network and different on the core network. So you have your application layer. Basically it's just text of your SMS or wherever. You optionally might have user data header. It's used in case of multi-part SMS, where you can indicate which part is it and how many of them is still pending. There is also next is the transport layer, transport protocol. This is probably the most interesting protocol. It's lots of fields. You can check the specifications. Relay protocol is basically used to acknowledge the reception and storage of SMS. It means that some entity has received this message and it was stored, and there is no need to care about it. And the control protocol is used just to acknowledge reception, but not storage of SMS. And when it comes to MSC, we basically replace both control and relay protocols with map. So we encapsulate the TPDU together with the application part into map forward short message, and then it travels to some SMS center or some other gateway MSC. So there's some messages, the most important for us, as you can see, CP protocol is quite easy. There is CP data that's commonly used to transfer some RPDU payload. CP ACK, it means that, okay, I received this. And CP error means that something wasn't received, or RP data, or is RP SMMA. RP data is used to carry TPDU. It's the transport protocol. And SMMA is used to notify the network that some mobile station has memory available to receive at least one SMS. There is also RP ACK, RP error. It's probably when there is no space left to store SMS, mobile would send RP error message with proper case. And on the transport layer, we have like SMS submit, SMS deliver messages, delivery report, and some SMS commands. As far as I remember, it can be used to, for example, remove already sent SMS from SMS center. There was something about this in specifications, or even modify. So you can basically send some SMS and then modify it if you are quick enough, I think. So that's how it works in commercial networks. There is SMS center, there is mobile station. So when you send some mobile originated SMS, first of all, of course, the channel establishment, authentication and ciphering optionally happening between the MSC and the mobile station, or sometimes SGSN also can be kind of a relaying entity of mobile originated or mobile terminated SMS. Mobile station basically sends CP data, like not SMS submit encapsulated into RP data, encapsulated into CP data. The network just confirms that it just received this payload and sends, now it requests some information from the VLR. And usually some commercial networks have kind of gateway MSC. So it's kind of central router for commercial networks. So your serving MSC basically initiates TCAP transaction to the gateway mobile switching centers and forwards the TPDU payload inside this map mobile originated forward short message. And the gateway MSC would take care about forwarding this message to the SMS center where it's going to be stored. So as soon as SMS center confirms that the message was received, we actually send some acknowledged message on the map side, and then we confirm to the mobile station that your message were stored. So we say RPAC. And then mobile station confirms that it's received this RPAC and sends CPAC, just to be sure. Okay, and in case of failed delivery, the SMS center may reject this SMS, and so we say NAC, and we say RP error with some cause that something went wrong. And in case of mobile terminated SMS, things get more complicated. Like first of all, the SMS center forwards mobile terminated message to the gateway MSC, Then the gateway MSC needs to know which MSC to contact, where is the subscriber for which this message is going to be forwarded. So it contacts to the HLR using map send routing info for short message, as far as I remember. And it basically indicates the MSISDN of subscriber, and the result, the response should contain either IMSI or LMSI. It's a kind of TMC, but on the map. And the MSC number that we need to establish TCAP transaction with. So we establish transaction and forward mobile terminated short message to the serving SJSN or MSC of subscriber. Then there is a paging request happening, again, channel establishment, and then the serving SMS just forwards it using the same process like RP data, CP data, and so on. So RPAC from MS triggers map shortword MT forward message ACK, and then it's delivered. But we are not implementing TCAP nor MAP. In Osmocom, we are using GSAP, and there are a few reasons. One of them is that we don't have reliable implementation of MAP in C yet. We need to deal with ASN1 encoding, and we also need to deal with some lower layer protocols of MAP, like in which it's being encapsulated. So we use GSAP. It stands for Generic Subscriber Update Protocol. It's a simple TLV-based protocol that runs over TCP IPA connection. And we basically abuse Osmo HLR as the kind of GSAP router. Like there is no such thing like gateway MSC. We use HLR for that. So everything goes through Osmo HLR. And over a single TCP IPA connection, there is no such thing like multiple connections. And yeah, there is no direct communication between the core network entities. Everything is done through Osmo HLR. So we have the following GSAP message types. Basically, they are quite similar to MAP messages to be able to easily convert between GSAP and MAP. So there is mobile originated forward short message, like request, result, and error. That's usual variations of messages in GSAP. Mobile terminated message and ready for short message. This message is used when either mobile station indicates that it has some memory available, either it wasn't connected to the network, and when it does IMSI attach, the MSC should notify the SMS center that the subscriber is ready now. So we have some basic information elements like destination address, originating address, the TPDU itself, and more messages to send. That's more or less generic information elements from the map specifications. Alert reason, of course, also a part of this specification. But since we don't have TCAP, we somehow need to distinguish between kind of transmissions of SMS because we're still using a single TCP connection. So we basically expose RP message reference that's used to kind of properly ask to some, like to acknowledge some RP data or indicate some error. And we also expose the cause information element because we don't implement any kind of mapping between generic cause and RP specific. So that's how it looks like, or probably. So the first part is the same. Mobile station establishes some SDCCH channel, for example, sends RP data with SMS submit. The network forwards it directly to the HLR using mobile originated forward short message request. HLR should look for the destination address and should find the SMS center and just forward this message to the SMS center. And from the SMS center, we get either the result, which means successful delivery of this SMS, so we RP acknowledge the SMS. Either we get some error and we indicate this to the mobile station, so it's quite simple. And mobile terminated SMS delivery is a bit more complicated. I don't know. Can you see it or not? On the top part, we have like SMS center basically initiates mobile terminated SMS transmission. And at that point, it doesn't know the message reference that's going to be used because it's assigned by Osmo MSC. So we use any invalid value for message reference. So it's getting forwarded to Osmo HLR. Osmo HLR connects to Osmo MSC, forwards this message. Then Osmo MSC establishes an SDCCH channel with subscriber and just forwards it. So we also get either empty forward SM result or error message. So what we basically support is mobile originated message delivery, mobile terminated message delivery, and kind of alerting when mobile station has some memory to receive some SMS. We have, I think, more or less complete TTC and testing coverage. The only part that's probably missing now is proper handling of multi-part SMS. The problem is that the SMS center may indicate that there are some more messages to be sent. Like if you are running behind the limit of 160 characters. So the MSC should basically keep connection until the last part. All the parts are delivered because there is no need to terminate and establish connection again and again. It would just waste resource wastement. The current reference counting implementation in Osmo MSC doesn't allow to implement this properly, so I'm looking forward for the patch of NIRS to be merged. So hopefully it will make everything simpler. Regarding the GPRS packet switch domain, I don't think it's that important for us to support this kind of delivery at the moment. And another important thing is that SMS over GSAP breaks SMPP support. You cannot have SMPP and SMS over GSAP at the same time. Because, for example, if some message is getting sent over SMPP, it can be forwarded to Osmo HLR because we don't tag from where does it come from. It can be solved, I think. So that's why it's disabled by default. And if you need to enable it, you just go to the VTI and just set this SMS over GSAP parameter. So I was going to show some message examples in Wireshark. The recent version of Wireshark should support all GSAP messages we have at the moment. And here is what's happening. So this is mobile-originated mobile-originated SMS transmission. So mobile station initiates a connection with service request with short message service, and then it just sends the, as I already said, RP data inside CP data. So the network does acknowledge reception of this, and then it basically forwards to the HLR. I will somehow make it bigger. So IMSI is a mandatory part of every GSAP message. Then we have message reference. It was 42 in this particular example. We have destination address. It's most likely the number of SMS center. And we have originating addresses that's just MSI SDN of subscriber that sent this SMS. And we simply encapsulate TPDU of SMS into our GSAP message, just like map does. So there was no text. And then we receive acknowledgement for that message reference. It means that SMS was delivered. There is also, I think, ready for short message. Yes, it when the mobile station notifies that it has some memory available, so we just forward it to the HLR, to the SMS center. There is mobile terminated message example. So it's this moment Osmo HLR initiates transmission to Osmo MSC. Then we initiate paging procedure. Then we get paging response, send this to the mobile station, and so on. So as soon as mobile station acknowledge this RP data, we just send forward some result with the same message reference. That's the key point. I think that's more or less it. If you have any questions, microphone is yours.
So yeah, the question is, why are you routing it through Osmo HLR? I guess because you need some information stored there, but why it was decided to do it like that and not have some other process outside of Osmo HLR to actually request information to Osmo HLR when it was needed?
Well, it was a kind of decision to make HLR kind of a central gateway like commercial networks do. But in the case of commercial networks, it's called gateway MSC, but we have kind of gateway HLR. So it's simpler, and probably Harald can.
But still, the gateway is a separate entity, right, from the HLR? Or
no,
from the MSC in that case?
It's a part of Osmo HLR. And we are
yeah, in our case it is, but not in commercial networks.
Not in commercial networks, of course. HLR in general is not dealing with SMS delivery.
Yeah, so I'm just wondering why not just having it in another process, you know?
We would have to kind of complicate our GSAP connections. We would have to implement direct communication between like SMS Center and Osmo MSC. And in our case, Osmo MSC is just a TCP client that connects to Osmo HLR, and that's it.
So yeah, basically you want to have a simple setup for the non-map use case. And simple means you want to have as little of the complexity of setting up, you know, extra point codes and extra routes and all the kind of stuff that you would need on whatever level. You just want to have a simple single TCP connection and that's how Osmo MSC has always handled it. And now you want to be able to swap in either to use Osmo HLR or to swap in whatever other gateway. So I'm not sure what advantage it would be to split that up into separate functionalities, because either you want to interoperate with a map or diameter or whatever external network, and then you need that gateway, and for sure you will not use Osmo HLR, or you will be using Osmo HLR, but then there's no point in having a gateway. So I think there's a very clear distinction between those two use cases, and I don't think there's a need to mix them in any way and complicate the network setup.
Actually, maybe one can comment because they are at the moment developing some kind of converter between just GSAP and MAP. So yeah, it works. It just works.
Yeah, so one port it's okay.
So they basically don't use Osmo HLR.
Yeah, so we don't use Osmo HLR as Harald said. So it's okay. You just use all GSAP traffic on one port, so it's okay.
Is this gateway open source?
No, okay. Because we use TCAP and MAP and SS7 stack. It's not open source, so that's that's right.
So now we can pretty much split up SMSC from MSC using this protocol and move SMPP, for example, there. In this case,
definitely
the problem gone.
That's actually how commercial mobile switching centers work. There is no SMSC in them. It's usually a separate process.
So related question then, how did you test it? What you used on the other end of this connection?
I usually use TTCN3 test cases. Of course, you can implement something in C, but it just works with TTCN. I'm actually thinking about some little proof of concept implementation of SMS center that would just store something in the SQL database, just to show that it works. Maybe, but I would need to do this IPI. I don't know. Oh, okay. That would probably take. Makes sense. Any more questions, I think? I think Holger had some questions.
No, it's resolved.
Okay.
Thanks.
Thank you.